Let us do question number 5. It's about partial differentiation. You are welcome. In partial differentiation, you have more than 2 variables. For example, variable x is equal to x squared plus y squared. When you want to differentiate in this case, you have to keep one variable constant. Like in this case, you can differentiate z with respect to x when you are keeping y constant. You can also differentiate z with respect to y when you are keeping x constant. And let us, for example, in this simple case, we see how we can differentiate. In partial differentiation, we write the symbol for differentiation as carry d. For example, when you want to differentiate z with respect to x, you are going to write dz over dx. This means here that you want to differentiate z with respect to x. And in our case, you are required to keep y constant. Carry dz over carry dx is equal to differentiating x. Here you are going to get 2x, and since our y is constant, when you differentiate a constant you get 0. Therefore carry dz over carry dx in our example is equal to 2x. When you want now to differentiate z with respect to y, you also write as carry dz over carry dy, and in this case you are going to keep x constant, and therefore you get the answer as 0. That is when you differentiate the constant x squared, you get 0 plus 2y. That is when you differentiate y squared with respect to y, you are going to get 2y. Therefore dz over dy is equal to 2y. And when now you do the second derivative, differentiate dz over dy, you differentiate the answer you get with respect to y, that is d over dy. That is differentiate dz over dy with respect to y. It is also same as writing d squared z over dy squared. And for example, in this case, dz over dy, differentiate this one for the second time with respect to y, that is d over dy, which is equal to d squared z over dy squared. When you differentiate 2y, you get 2. Let us now go to our problem. Look at this problem. It is involving partial differentiation, because we have got the 3 variables, that is z, x, and y. So we are going to differentiate z with respect to x when we are keeping y constant, and then we differentiate y with respect, we differentiate z with respect to y when we are keeping x constant. And remember, in this problem we are required to get d squared z over dx squared. Also d squared z over dy squared. The other one is d squared z over dx dy. All these are second derivatives of this function. So we want now to get d squared z over dx squared. This one, as we have said earlier, we are going to differentiate z with respect to x, that is dz over dx. The answer we get, again, we differentiate it with respect to x, and that will give us the second derivative of this function. And let us go. Let us get dz over dx of this function. So dz over dx of this function. We differentiate z with respect to x when we keep y constant, and it becomes 2x, and since y is constant, therefore this becomes cos y. And let us now differentiate again dz over dx. We differentiate it with respect to x again, so that we can get d squared z over dx squared. So let us differentiate this with now respect to x again. 2x, when you differentiate it, we'll get 2. Cos y, since it is a constant, it remains as cos y. Cos y. And then we have dz over dx squared as 2 cos y, and that is the answer for the first part. We want to get d squared z over dy squared. Also here we are supposed to get dz over dy of that function. Then we differentiate it again with respect to y, that is d over dy there. And let us start with the dz over dy of this function. And remember, the function is z is equal to x squared cos y. That is a function that we are going to differentiate so that we get the second derivative here. So dz over dy therefore becomes, and in this case, remember, we are supposed to keep x constant, therefore it remains as x squared. Then we differentiate cos y, because y now is a variable we are differentiating. We get negative sine y. So here it is negative sine y. So we put negative at the end there. Let us now do the second derivative of this answer here. D over dy of this function, that is d over dy of this function, that is x squared sine y. That function is equal to, we want to differentiate this with respect to y. So we get, so x is constant, so it becomes x squared there. So if we differentiate sine y, we get cos y. So this is cos y. And we have gotten the other part, that is d squared z over dy squared. Now we go to the other part. We want to get the second derivative of here d squared z over dx dy. So here we are supposed to get the second derivative. How? We are supposed to get dz over dx. That is the first derivative. Then we differentiate the second derivative with respect to y, that is d over dy. dz over dx is equal to 2x cos y. Already we know that. We want to differentiate that with respect to y, so that we can get the answer there. We want to differentiate that with respect to y. So when we do that, this one, we differentiate this one with respect to y. So 2x will be constant, so we write it 2x. Then we differentiate now cos y. If we differentiate cos y, we get negative sine x, negative sine y, and that is the second derivative in that case, that is d squared z over dx dy.